how would you land it on the moon? That question continues to drive debate around Starship, a vehicle that is exceptionally large, extremely tall, and currently designed without landing legs. Will Starship ultimately gain landing legs or will it not? That decision rests with SpaceX. The more immediate question is how Starship could safely touch down on the lunar surface if landing legs are not part of the design. One unconventional concept under consideration is sideways landing, an approach that offers surprising efficiency and several unique advantages. After more than 50 years since the last crewed mission to the moon, humanity is finally preparing to return to this natural satellite. However, the challenge is far greater than many expected. Landing on the moon remains extremely difficult, and many modern landers have failed, even those with low horizontal designs and dedicated landing legs. Examples include intuitive machines landers such as IM-1 Odysseus and IM-2 Athena. This raises a critical question. How can a vehicle like Starship land safely on the moon? Starship is enormous, standing at over 50 meters tall with a diameter of just 9 meters. This means its height is more than 5.5 times its width. SpaceX is even planning future versions such as the V4, where the height increases further while the diameter remains unchanged, making this imbalance even more extreme. Its height alone exceeds that of many rockets, let alone lunar landers. The vehicle is also designed to land vertically, which significantly increases the risk of failure. Compounding the problem, the current Starship design does not include landing legs for stabilization. Even on Earth, Starship requires support stands to remain upright, something that would not be available on the moon. The lunar surface itself is uneven and unpredictable with slopes, cracks, and rough terrain. Even a minor surface irregularity could cause Starship to tip over. If that were to happen, the consequences would be catastrophic. Starship would still contain fuel and a strong impact could result in an immediate explosion. All onboard payloads would be lost. More critically, Starship HLS is designed to carry astronauts, making crew safety the top concern. So, how could SpaceX address this problem if it chooses not to add landing legs? There is one clear answer that has been proposed. Sideways landing. At first glance, it sounds unusual, but the concept offers several compelling advantages. The most significant benefit is improved stability. By landing in a tilted or horizontal orientation, Starship would have a much lower center of gravity and a much larger contact area with the lunar surface. This would greatly reduce the risk of tipping over and make balancing the vehicle far easier than attempting a vertical landing. A second major advantage involves surface operations. Once Starship is tilted, nearly the entire spacecraft would be much closer to the lunar surface, including the payload bays and crew living quarters. This would eliminate the need for large elevators to transport astronauts and cargo from heights exceeding 40 m. Instead, simple stairways or short access systems would be sufficient, allowing astronauts to move easily between the surface and the vehicle and enabling efficient unloading of payloads. Another advantage lies in long-term potential. A tilted Starship could be more easily converted into a permanent lunar base. This would allow SpaceX to rapidly establish a stable habitat for astronauts on the moon. Starship already contains a large and advanced interior designed to support crews during deep space missions, and with further modifications it could support long-duration living and scientific research on the lunar surface. This concept is often referred to as Moon Base Alpha. If SpaceX were to pursue this idea, additional modifications would still be required. Fuel tanks would likely need to be removed or repurposed to expand living space. A protective layer of lunar regolith could be added to shield the structure from dust, debris, micrometeorites, extreme temperatures, and radiation. One question naturally follows. If Starship is converted into a lunar base, how would astronauts return to orbit? One possible solution would be to carry a smaller ascent vehicle inside Starship HLS. This vehicle could be stored in the payload bay and would not need to be operational until it was time to return the crew to lunar orbit. Its sole purpose would be crew transport, making its design relatively simple. The larger challenge would be determining who would design and build such a vehicle and how it would integrate with Starship operations. Because of these uncertainties, converting Starship into a lunar base remains a long-term concept rather than an immediate plan. It's unlikely to be implemented on the first missions, but could become viable during later expeditions. Despite its benefits, sideways landing introduces several major challenges that cannot be ignored. The first and foremost significant challenge is the landing support system itself. In addition to the main engines, Starship would require powerful thrusters, likely mounted near the forward section of the vehicle. These thrusters would need to assist with deceleration while also counterbalancing the main engines during landing. The aft engines and forward thrusters would need to work together to slow the vehicle, rotate it from a vertical orientation to an inclined position and then gently lower it onto the lunar surface. This process would require extraordinary precision. These engines and thrusters would also consume large amounts of fuel, meaning SpaceX would need an efficient method of fuel management and distribution. If Starship were later required to launch again to return astronauts to lunar orbit, the thrusters would face an even greater challenge. They would need to lift the forward section of the vehicle before the main engines could fully ignite for liftoff. Overall, this approach would require substantial modifications to Starship's propulsion and control systems. The second challenge involves Starship's shape, its cylindrical, bullet-like design that while it may not easily tip over when laying down, it could roll. This presents another serious risk. To prevent this, additional structural supports or stabilizing bars would likely be needed at both ends of the vehicle. The third issue concerns the interior layout. Starship was originally designed to operate vertically. If the vehicle were placed on its side, internal spaces could be disrupted and unsecured payloads could shift or collide. Converting the interior for horizontal operations would take time and careful planning. Ideally, SpaceX would need to design Starship from the beginning to allow smooth transitions between vertical and horizontal configurations. Structural concerns also play a major role. Starship's structure is strongest when forces are applied along its vertical axis. When positioned horizontally, the stresses on the hull and internal tanks increase while overall structural strength decreases. Loads that are normally distributed evenly could become concentrated in specific areas, increasing the risk of damage. While lunar gravity is much lower than Earth's, these stresses cannot be ignored. To address this, Starship's hull and fuel tanks would need significant reinforcement to withstand horizontal loads and impacts. Another structural challenge involves fuel delivery. When Starship is horizontal, fuel flow to the engines become less efficient, which could negatively affect engine performance. This issue would be especially critical during the transition from a horizontal position back to vertical for liftoff. Unstable engine performance during this phase would pose a serious risk. SpaceX will likely need to add backup pumps or alternative fuel management systems to ensure reliability. Clearly, sideways landing requires extensive analysis, redesign, and testing. If SpaceX chooses to pursue this method, it would need to be implemented early and refined through repeated testing. However, if these challenges can be overcome, sideways landing could address one of the greatest concerns surrounding Starship HLS, which is the risk of failure due to its extreme height. For me, the sideways landing concept would be an impressive way to demonstrate Starship's versatility. That said, I still find rockets, spacecraft, and landers equipped with landing legs more appealing. There's something inherently satisfying about a vehicle standing firmly on its own. If you feel the same way, respond with Lego in the comments. From a practical standpoint, landing legs remain the most efficient and straightforward way to stabilize a vehicle, especially during early missions. At that stage, there would be no external support systems available, and SpaceX may not want to heavily modify Starship to enable sideways landings. However, adopting landing legs would require major upgrades to Starship, particularly in the aft section. The legs would almost certainly need to be foldable so they could remain protected during ascent, flight, and descent, avoiding unnecessary bulk or damage. During landing, these legs would deploy to provide stability following a concept similar to the approach SpaceX has successfully used on Falcon rockets for many years. Because the legs would need to fold neatly into the vehicle, critical systems such as the engine bay and the fuel plumbing that connects the engines to the tanks would have to be repositioned or redesigned. Starship is an extremely large vehicle and its landing legs would also need to be large and robust to support its mass. This implies that the structural changes required in the aft section would be substantial. If these challenges can be resolved, a legged version of Starship would still offer significant value and flexibility for SpaceX. Such a configuration would likely be used during the earliest missions to the Moon and Mars, as well as for potential Earth-to-Earth transportation. During these missions, SpaceX would not yet have access to infrastructure such as holding arms or concrete balancing platforms. In remote locations on Earth without support systems, Starship could also land on drone ships or floating platforms, both of which require landing legs. In this sense, a legged Starship would serve as a pioneer, enabling SpaceX to operate in new and undeveloped environments. Meanwhile, a version of Starship without landing legs would likely be reserved for sideways landings when support systems are not yet available or for specialized missions such as converting the vehicle into a surface base. While it could still perform pioneering tasks, it would face more limitations. Designing and integrating powerful support thrusters is likely more complex than simply adding landing legs. In the long term, SpaceX will likely aim to develop a dedicated landing support tower system. This approach would be fully compatible with the non-leg Starship design currently under development. It would also enable faster recovery, refurbishment, and reflight compared to other landing methods. The challenge is that building such infrastructure would require dedicated missions to transport materials, landing pad sections, and support equipment. This process would be both time-consuming and labor-intensive, and additional solutions would still be needed to safely support Starship landings. There is still much to explore when it comes to Starship's role in space exploration. Its size and design present both extraordinary opportunities and significant challenges as Starship continues development and works toward missions to the Moon and Mars. These design questions will remain central to ensuring the safety of both cargo and crew. Will Starship be able to land successfully on these missions, and which landing method will ultimately be chosen? Those decisions rest with the SpaceX engineering team. Without landing legs, sideways landing offers a compelling alternative. Once these challenges are addressed, Starship's true potential will become clearer. Its capabilities could enable long-term human exploration in ways no other vehicle can match.